at least it will show you the equation and everything. That will be the best way, since you've not had the lectures. Yeah, because I'm sure during the lecture they'll have taught you all this, but since you've not had the lectures, it's good you see this very clearly, right? You recall the equation in the linear regression, right? That we did last week, right? Hello, you're not in.
Yeah, we can hear you, sir.
Okay, great.
Yes, sir.
Okay. Yeah, so, okay, great. So over here now, we have this equation here, right? Now the difference is this, our equation, it calculates our coefficients as log odds, the logarithm of, or logarithm, right? Log odds, which is the logarithm of as whatever the value of the of hours above 70 over 1 minus hours above hours greater than 70 and all that. So that's the equation, right? Which is a bit more complicated than the one we saw in linear, which was just straight up y is equal to a plus bx, straightforward, right? But don't bother about cramming the equations; those are not the issues, right? Yeah. So these are hypotheses which you already know. We also tested this hypothesis with chi-square. Now, what we see here is the B, which is our log odds. So what we have here is the B is our log odds, the logarithm of our odds ratio, right? And what it tells us here is basically the direction of our association. Now recall that each time you're thinking about measures in statistics, always think about two things. Think about magnitude and direction, right? So, but this doesn't really give us straight up magnitude. It tells us more about the direction. So we have it B here, or rather interpretable, right? Because the log odds. So we have a negative sign here, right? Which tells us that the assumption is in the opposite direction. We have a standard error which is normal, but our p-value here is what? 0.19. Now, what does that mean?
We reject the null hypothesis.
Wait, calm down. Is this statistical significant or not?
Significant.
Good. Now, recall that we did a chi-square as well, right? That showed us that there was an association, right?
Yes.
And this one, and we've now done the logistic regression, and it's telling us the same thing, right? Now,
yeah,
it's not the figure. The number will not be the same, may not be exactly the same, but it is statistically significant. That's the important thing, right? What so then the last one is the important thing here. It converts your beta coefficient to odds ratio, which makes more sense, more meaning, right? So we have an odds ratio of 0.436. So this would mean that the odds, now listen to the words I'm using very carefully. I'm sure they will teach you other things about risk ratio and hazard ratio, where the terms used are likely, but in terms of odds ratio, we don't use the word likely, we don't talk about likelihood, right? So the odds of working greater than 70 hours is 0.436 times among females compared to males. Can you see where the interpretation comes in, right? Because we use 0 as we use males as our reference value or our comparison value, right? So whatever we get is compared to the males. If we had chosen last as our reference value, then the results here the numbers here would have been different, but would have now said whatever we got there would have been among males compared to females. Is that clear?
Yes,
Any
sir.
question at this stage, or we are all on board?
Can hear you, sir.
No, you can hear me. It's different from I understand you.
Yes, sir. We understand.
Yes, sir. I think I get it.
You think you get it? You think you get it, not the same as you got it. Is everybody following that? I just want to be sure I'm carrying everybody along because only 2 people are speaking in this class, and that's not very.
Yeah, I understand.
Okay. All right. I've heard a female voice, so that's good. If 2 females, I have 2 males and 1 female. No, we need more females so that we can get a statistically significant.
I'm following, sir. Yeah, I'm following.
More males. Do you only have 1 female in this class? Okay, great. So let's go on. We are out of time. Yeah, so that's it. And then, sorry, p-value.
Excuse, sir.
Yeah.
The negative sign in front of 0.830, does it have any meaning?
Yeah, that's what I told you before. But let me explain it now better now. I talked about that it has given us the direction of association, but didn't give us the magnitude. Or interpretable magnitude. But we now use the odds ratio instead, which gives us both direction and interpretable magnitude. How do I mean? When you multiply 0.43 by whatever value you have in the equation, do you get a higher value or a lower value?
Higher value.
Do we all agree with him?
A lower value.
Beautiful. It's a lower value. So that is why you are having a negative sign here. When you see a negative sign here, it means that your odds ratio is going to be less than 1. Do you understand?
Okay.
Okay. It's not convinced. Yeah. So it means that you can say that the direction is in a negative direction because when you multiply it, it's less than 1. Right? And one thing this output did not do, which okay, yeah. I don't think it's in it didn't come up in our lecture at all. I wonder why. So you can actually tell SPSS to give you the 95% confidence intervals as well, just like we had with the linear regression, right? So, and if we recall, when we're doing comparison of means, when we talk about significance with respect to 95% confidence interval, what did we say last week? How do we know if it's significant or not?
It's like if it crosses, is it like if it crosses 0?
Beautiful.
Not significant.
Yes. So if it crosses 0, that's with our comparison of means, right? If it crosses 0, it's not significant. And remember the rationale behind that. We were subtracting one mean from the other, right? To know that, so our null hypothesis is that there is no difference between the means of 2 samples. So how do you know there's no difference? Difference is by subtraction, right? Are we following?
Yes.
Good. So if there's no difference, if the mean of one sample is 5 and the mean of the other sample is 5, then there's no difference. So if 5 minus 5 gives you 0. So so once our 95% confidence interval crosses 0, then it is not statistically significant. Do you remember that?
Yes.
Okay, so now I want
Yes,
to go to the, so now I want to go to this one now. Unfortunately,
Sorry,
here.
sir.
Sorry.
Sorry to drag you back, sir, but I don't know. Maybe I'm the one that is having problem with my own. The result I'm getting is not also on the slide. I'm getting it.
Don't worry, we've already established that some of you have the wrong data set. So don't so follow what we have on the slide, not what you produced. We found that some data sets are not correct. So don't. Sorry.
I said I have the same data set you have, and I've been having the same answers up until this point.
Well, that means the approach you missed a step or did something wrong, because we followed him just now when he did it, and we got the same result as on the slide. So that means there's something wrong with what you did. I would have said, I'd have asked you to share your screen, but we're out of time already, so you can go back to see what you did wrong.
Sorry, sir. I think I had. Sorry, can I speak?
Yeah.
I have the same. I assume I have the same issue that the previous speaker had. I have similar results as you have on your page, but for the beta, I have 0.830. There's no negative in front, and the expected B I have is 2.294, as opposed to your 0.4.
Maybe I'll share the screen just now.
No, I wasn't what I shared my screen.
But who shared the screen? The person who did the analysis just now got this figure, right?
I wouldn't be too sure of that. I don't know.
Okay, we are out of time.
I think he did.
Sorry, we're out of time, so I wouldn't want to draw us back. Possibly, there are two things that are possible. One is either there's a problem with the data set, or two, there's a problem with steps. Perhaps it's the data set, but what's more important is this, understanding how to perform it and how to interpret it, right? So that we don't, because we're already 17 minutes out of time, so we can't go back to start checking what went wrong. But just know how to perform. If you follow these steps, you get outputs similar like this. And then how do you interpret the output that you see? Let's focus on that, right? Are we on the same page?
Yes.
Okay, great. So, yeah. So we infer that the odds ratio is that, and then yeah. So okay, I was trying to explain how if we had included confidence 95%, I would have wanted us to go back to do that, but there's no time. But when you're using odds ratio, you are not thinking about 0, you are thinking about 1. So if the odds ratio, if the 95% confidence interval includes 1, then it is not significant. And you know the reason why? I'll explain because of time. Or can anybody guess why is that way as against the comparison of means? Nobody, okay. Now, odds ratio is a ratio, which means it is something divided by something, right?
I don't know why.
Okay, so odds ratio is a ratio, which means it is something divided by something. It's comparing two things, right? Do you understand?
Yes, sir.
Yeah, ratio compares two things. So if you have, so you have which you can convert to a fraction and have a numerator and a denominator. So if there is no difference between the numerator and denominator, that means they're the same. What are you going to get? 1, isn't it?
Okay, sir.
Yeah. So that's why with odds ratio, interpreting the 95%.
Sorry, I didn't get that, sir. Sorry, sir.
Well, everything I'm saying is outside the scope because it's not on our slide. So maybe we can move ahead because of time. Oh, let me just go over that quickly, but time is going. Now, with the means, when we compared means, we were talking of difference in means, right? And we used one mean divided by the other, one mean minus the other mean, saying that if there's a difference, A minus B will be equal to 0, right?
Yes, sir.
You understood that? Now with the odds ratio, which we didn't present 95% confidence interval here, but if we had presented it, if you're going to interpret it, we don't interpret it in terms of it containing 0, we interpret it in terms of it containing 1.
Yes.
Because it's a fraction, not subtraction.
I get it.
Okay. So yeah, so you reject on hypothesis, know that we've done that. So we conclude that female resident doctors had lower odds of working greater than 70 hours compared to male counterparts. I think this is clear, right? Yeah.
Yeah. Hi. Yeah, thank you. I think it's clear up until now. I'm just, it's just a little fuzzy in my mind. Why at this point we are looking at, in terms of statistical significance, why we are actually looking at the log values, as opposed to the p-values?
No, we are looking at both. The p-value tells you, now recall that with the chi-square test, we are testing association. We are not trying to predict or predict anything. I mean, we did that also last week. We yeah. So so what the recall when we talked about, we did ANOVA, right, last week, and we recall that what we said last week when we did ANOVA is that ANOVA tells us whether one of the samples is different from the other, right? So if you have 3 samples, it gives you a p-value which tells you that at least one of the 3 you've tested is different from the other, is different, right, from the other samples. So that's what ANOVA tells you, but it doesn't give you any magnitude to it. Same thing with chi-square. Chi-square tells you there's a p-value which tells you that there's an association, and that's why we did a chi-square first of all to see, and it told us that there is an association, but it doesn't tell us how predictive it is. It doesn't give us anything about magnitude or even direction of association. That is why the regression is superior. Now, the regression has given us a p-value, first of all, telling us that it is significant, right? And then went ahead to give us an odds ratio to measure the magnitude and direction of that significance. With the chi-square, this was the same data we used for the chi-square. We could not, there was no way we could have said that that the odds of working 70 greater than 70 hours is this amount of times among female compared to males, or that we could not conclude from our chi-square that female resident doctors have lower odds of working greater than 72 hours compared to male. Our chi-square cannot tell us that. All it tells us is that there is an association, but it doesn't tell us anything about, it doesn't tell us the magnitude or the direction, whether it's higher or lower. It doesn't tell us. It doesn't tell us by how much. I don't know if that's clear.
No, so I have a problem getting the logistic regression table. I went and analyzed and to regression binary logistic, and I can't get the table. It's giving me an error.
We are out of time, so we can't really go back there now. I mean, that's why I asked someone to present and show. But I mean, we are out of time. I know, I mean, we were supposed to end about 24 minutes ago, and we are still here. And I am stretching because I have other things to do today. Today's Saturday, and it's just.
I think we get the recordings. You can watch the recordings.
Yeah, so yeah, beautiful. The recordings are there, so you could go through the recordings and see the processes. But we don't have the time to go through everybody's challenges into it. So, but there are 2 things: either the process you did was wrong, or we've established some data sets were actually not correct. So it's one of those 2, right? So that's what. So this tells us magnitude and direction. Now, as a general rule, in interpreting these various ratios, now you're going to, I'm sure tomorrow's lecture, they will teach you, they're going to teach you about hazard ratios, risk ratios, and odds ratios. today we characterize odds ratios with logistic regression. Now, if your if the construct, like your here is okay, here they used hazard ratio as an example. Let me use the word odds ratio because that's what we did today. So if the odds ratio, for example, was 1.4, an easy way to interpret, now here we interpreted it, we just said 0.436 times among that, which I asked you, is it higher or lower? And you said it is lower because when you multiply this, it gives you a lower value than 1. And that's why we also have a negative value here with the beta value because it's lower. So it tells us that females have lower odds of working that. Now, if we had a value of 1 point something, it means that females had higher odds, and that higher odds was by 1.4, right? So if you had a 1.4, what you just need to do is an easy way to interpret it in percentages would be to subtract 1 from whatever you get. And then if you subtract 1 from whatever you get, you're going to get from 1.4, you're going to get 0.4, right? And when you multiply that by 100, so you're converting this into percentage, you're going to get 40%. So you interpret that as, so females had 40% more, this is hazard ratio, so you don't likely, but in terms of odds ratio, you say females had 40% higher odds, right? That's for values greater than 1, but less than 2. Is this clear to everyone? Or is there a confusion?
Yes, sir.
There's a confusion, or it's clear?
No, it's clear.
Is this clear to everyone? There are 15 people here. I just want to be sure that I'm not speaking Greek to everyone.
Oh, I'm following.
Yeah, it's clear.
Oh, okay. Thank you. So 1.4, 40% higher. Now, when you have it less than 1, like we did have, so for example, 0.83, you subtract 1, you subtract from 1, right? So 1 minus whatever value, and then you get 0. So in this particular case, it was 3, so you get 0.17. You convert it to percentage, you get 17%. So that means that they are 70%, they have 70% less odds, because if you're using odds ratio, 70% less odds. If it was relative risk, 70% less likely, right? That's clear as well, right?
Yes. Yes, sir.
Clear, right? Okay, good. So the third way to interpret as well, for those greater than 2, is you just do nothing and just report it as is. So women are 2.3 times more likely or have 2.3 times greater odds to do this than men. So this is the basic way of interpreting all, but to make it more interpretable, you can use percentages, right? Like if you recall the previous slide, we did not use percentage, even though it was less, and that's how I said 0.436 times among female compared to males. But in everyday language, it makes it a bit difficult for someone who is lay